Start. See, first of all, today we have to talk about light. Now, when I say light, what do I mean by light? When I am saying light, what do I mean by light? Light is nothing but, we call it as an electromagnetic wave. In short, we call it as EM wave. Okay. Now, when you say electromagnetic wave, these are characterized by say suppose this is the magnetic field, okay, and so this is the electric field, and this is the direction of propagation. So what I am saying is that magnetic field and electric field are perpendicular to each other, like this, perpendicular to each other, and perpendicular to the direction in which they are moving. See, magnetic field, electric field, perpendicular to each other, and they are moving in this direction. So it is like if the direction of propagation is x-axis, magnetic field is on the y-axis, electric field is on the z-axis. So this is how they are propagating, but magnetic field is in the y-axis, electric field is in the z-axis. Okay, like this. Is this clear? These waves are termed as electromagnetic waves. Now, how do we identify the electromagnetic wave or differentiate it from others? You have two things. One is the wavelength. It is represented by lambda. Okay? This is B is silent over here. Okay? So you will call it as lambda. B is very slight sound comes, lambda. Okay, so most of the times we say lambda only. Now this is, when we say that there is a wave, the wave actually travels like this. Okay. Now this is called as the crest, trough, and this is called as the crest. So what do we say over here? That the distance between two consecutive crests or distance between two consecutive troughs is termed as lambda. This is termed as lambda. Okay. Or see, a wave actually has to cover suppose if it is 0 degree, this is 90 degrees, this is 180 degrees, and then this is 270 degree, and this is 360 degree. So if you see in terms of a circle, if I draw a circle, you see, it starts from here. Here you have got 90, here you have got 180, here you have got 270, here you have got 360. So this is the upper half. See, this upper half is this one, lower half is this one. Okay, so this is how the angles are calculated. So this full length, when it moves from 0 degree to 360 degree, this length of the wave, this is termed as the length of the wave, is termed as length of the wave and is termed as wavelength. Okay, this is length of the wave and we call it as wavelength. Clear? Fine. Now the second thing is frequency. This is nu. It's like NU, nu. Okay. Now it is the number of times a wave passes through a particular point in 1 second. In 1 second. Okay, is this clear to everybody? So, and its unit is per second, that is second inverse, or hertz. Hertz is written as Hz. Okay, and this is per second. Clear to you guys? Tell me. देखो बेटा, when I am saying this thing, what I am saying is that we are starting from 0, we go up to 90, we go to 180, we go to 270, we go to 360, starting from 0. So we go to 90, we go to 180, we go to 270, we go to 360, and that is how we are completing one length of the wave. This quarter is 90 degrees, another 90 degree, another 90 degree, another 90 degree. So when the full circle is completed in terms of a wave, it is termed as the length of the wave and we define it as wavelength. Is that clear? So now you see, we are saying that the frequency is inversely proportional to wavelength. We are saying frequency is inversely proportional to wavelength. Why we are saying so? Suppose this is a fixed point and this is the wavelength. Okay. So you can see then how many times this wave is passing through this particular point. Suppose this is the wavelength, right? So you can simply observe when the wavelength is larger, the frequency is lesser. Larger wavelength, lesser frequency. Lesser wavelength, larger frequency. Now when you remove this proportionality sign, you will get c by lambda, where c is the velocity of light. Do you all know what is the value of velocity of light? Huh? Do you know the velocity of light? Three into 10 raised to power 8 meters per second. Fantastic. Okay, actually this is a part of modern physics only, which you will be studying in 12th class in physics, but we have to do it in chemistry, so I am teaching it over there. Okay, so in a way I can say that the light which is an EM wave has got two components, frequency and wavelength. Frequency and wavelength. Okay, and they are related by this formula: frequency is equal to velocity of light by wavelength, or frequency into wavelength is equal to velocity of light. Okay. Then we have got something called as electromagnetic spectrum. Now what is this electromagnetic spectrum? See, you start with say lowest lambda and you go to the highest lambda. Fine. So you start with say X-rays, then you reach to say UV rays, fine. Then you go to visible light, and then you go to say infrared, and then there is far infrared. So it's a bigger section. I am just picking up a small one which is important for us. So this is the visible section, and here we talk like this: VIB GYOR, VIBGYOR. Okay. So now what does it mean? That this red has got highest wavelength and V has got lowest wavelength. So understood this part? Clear? Fine. So this is a bit about light. This is a bit about light. When you talk about the energy that the light is having, we say that energy of light or EM wave is directly proportional to its frequency. Is directly proportional to its frequency. That is, E is proportional to nu. When you remove this proportionality sign, you will get H nu. What is this H? H is Planck's constant. The value is 6.6 into 10 raised to power minus 34 joule second. Okay. So as you can see, H is joule second, nu is second inverse. So this second and second inverse will cancel with each other. So E will be joules. So this formula is dimensionally correct. Now this was given by Max Planck. Max Planck's quantum theory. Now the question arises, from where does this theory comes up? Why do we need this theory at the first place? Why should I study about it? Actually, before Max Planck, there was a corpuscular theory of light, which says that light is traveling like a corpuscle. You know, corpuscle is something like this. You know, something which is used to cut the grass. So it just travels like this. And it is a continuous thing. But Max Planck observed it and he said, no, this is not right. Actually, he said that whatever is traveling, I mean, but the light, it is not travel it does not travel like this. It is not traveling like this. According to him, it travels like this. Zoom करेंगे इसके ऊपर. So what are these? These are called quanta. What is a quanta? Quanta is a discrete packet of energy. Discrete means alag alag. Discrete मतलब alag alag. These are individual packets of energies. Okay. So as per Max Planck, he said that E is equal to NH nu. So energy of the light or energy of an EM wave is actually equal to the number of quanta that it is having and multiplied by the frequency and the Planck's constant. So now how many quantas you are having over here? Zoom करेंगे और zoom करेंगे यहाँ पे. So you see, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 like that. So more the number of quantas, more will be the energy. What if I start removing these quantas alternatively? Okay, now you see quantas are less. Huh? Since the quantas are less, the energy carried by the wave will also be less. Fine. Okay, this is how the energy is actually traveling. It travels in the form of small packet of energy. Zoom out kariye. It travels in the form of small packet of energy called as quanta. Right? Now many a times they confuse you with this particular statement, that what is the relation between quanta and photon. For any radiant energy, any energy which radiates from one point to another point, we use quanta. But in case of light, quanta is termed as photon. Okay. So what is quanta? Quanta is mithai or sweets, and photon is laddu. Okay. So every laddu is a mithai, but every mithai is not laddu. So every photon is a quanta, but every quanta is not a photon. Understood? The question says, suppose 10 raised to power minus 17 joule of light energy is needed by the interior of the human eye to see an object. How many photons of green light are needed to generate the minimum amount of energy? Now see, we have to use the formula E is equal to NH nu or NHC by lambda, because nu can be written as C by lambda. Okay. So energy which is given to us is 10 raised to power minus 17 joules. Number of photons we have to find out. H is 6.6 into 10 raised to power minus 34, and we are given the wavelength 555. So this will be 3 into 10 raised to power 8 upon 550. Nanometers is 10 raised to power minus 9. Okay, this is how we have to solve it. So you will get n is equal to 10 raised to power minus 17 into 550 into 10 raised to power minus 9 upon 6.6 into 10 raised to power minus 34 into 3 into 10 raised to power 8. Tell me, now you guys can solve it out. This will be 10 raised to power minus 17 minus 9 plus 34 minus 8 into 550 upon 6.6 into 3. So 6.6 into 3 can be approximately written as 20. So this is 27.5 into, now 17 plus 9 is 26, 26 plus 8 is 34, alright. So we are getting 10 raised to power 0, that is 1. So there is some calculation error that we would be having, because 0.5 is not possible. So maybe this we have to solve properly. Okay, we have to solve this part properly. 550 by 6.6 into 3. Okay, so if you solve it properly, you will be getting 550 divided by 6.6 divided by 3. 27.7, approximately 28. So we have to write 28 only. 28. Yes. So this was the question. This was question number 1. Now, the question number 2 says that a photon of 300 nanometer is absorbed by a gas. So you see, there is a gas. Now it absorbs 1 photon. Fine. But it emits 2 photons. Okay. So he says now this is having lambda is equal to 300 nanometers. Okay. Now he says one re-emitted photon has wavelength 400 nanometers. Now this is having lambda 400 nanometers. So he is asking the lambda over here. Okay. Now if you apply, so let's say this is lambda 1, this is lambda 2, this is lambda 3. If you apply law of conservation of energy, fine, I should say E1, that is energy of this photon, should be equal to E2 plus E3. Do you all agree with me on this? So this is Hc by lambda 1 is equal to Hc by lambda 2 plus Hc by lambda 3. Right? Okay, man, fine. Now see, mane beta, Hc cancels out. So you will get 1 by lambda 1 is equal to 1 by lambda 2 plus 1 by lambda 3. Now you have to put down the values and get the answer. So 1 by 300 is equal to 1 by 400 plus 1 by lambda 3. You have to solve for 1 by lambda 3. Okay, is it clear? Clear to everybody? Beta, energy is given as E is equal to h nu or hc by lambda. That is why we are writing it like this. Okay. Now what does photoelectric effect means? Photo, now you know a photon. Electric field, you know. Electric energy, which is nothing but flow of electrons, right? So basically what happens over here, beta, see, this is a metal surface. Now the question arises, why do we take a metal surface? We take a metal surface because the electrons in the outermost shell are loosely bound, so they can be easily taken out. So let us say these are the electrons, these are the electrons, and now what happens? Wave comes and strikes. Now this is not a wave, this is basically photons having some packet of energy. Like this. Okay, fine. So when this photon strikes this electron ejects out. This electron ejects out, and it is termed as, now this electron is termed as photoelectron. And you see the photoelectron is moving in a particular direction. If the electron is moving in a direction, current moves in the opposite direction. If this is the direction of flow of electron, this is the direction of flow of current. Okay, they flow in opposite directions, right? So anyways, we just know that the electron is flowing. If the electron is flowing, the current is flowing. Okay, so this is how the photon on striking a metal surface ejects a photoelectron, and thus electricity is produced. This is what happens in photovoltaic cells, in the solar cells that we talk about. Nowadays everybody is talking big about solar cells. So this is what is happening in the solar cells, and the element that we are using over here, normally the metal that we use over here is either rubidium or cesium. Okay, fine. But now there has to be some maths over here, because every surface is not emitting electrons, and every time the electrons are not ejected out. So what is the condition? See, it's very, very simple. Let EI be the incident energy. Now what is incident energy? Energy So threshold energy is the minimum amount of energy required to remove an electron the surface of metal. Okay, fine. Now let us see over here. What is it that I am trying to explain? See, suppose this is the electron on the surface of metal. I want to eject it. Now see, it's not getting ejected. Moving but not getting ejected. Can it eject like that? I say, no sir, you have to give more energy. So there is a minimum energy which I require to eject it from the surface. Agreed? Right? Okay. Now see, I am explaining it from the starting Rania center. This is the electron on the surface of metal. Okay. I want to eject it. I want to take it away from the metal surface so that it starts moving in a particular direction. Because if it is moving in a particular direction, then electrons are flowing in a particular direction, so current is flowing in opposite direction. Right? Now how do I eject it? Dekho beta, if this is the electron and I want to eject it from the surface, I need to hit it with something. See? Right? Hit one. Dekho. Hit one. So I am hitting, I am striking my finger on this marker. So it is moving away. Right? So if this is the electron, this is the photon. The photon strikes and the electron moves out of the surface. Right? But suppose, what if I hit it like this? It's not moving out. Not moving out. Is it moving out? No. I need a minimum energy. Minimum energy. Then only the photon will be ejected out. So the energy with which I am hitting, incident energy, the minimum energy required to move it away from the surface, threshold energy. See, if I just have to remove it from the surface, I have to apply this much of energy. See? Now what is happening when I am applying extra energy? Tell me. What is happening when I am applying extra energy? My extra energy is changing into what? Suppose 1 joule is required to remove it and I give 5 joule. So what will happen to the rest 4 joules? Arey bhaiya, these are photons. Kinetic energy, yes, it is the kinetic energy. So you see, what will be the formula now? EI is equal to ER plus kinetic energy. Plus kinetic energy. EI is equal to ER plus kinetic energy. Incident energy is equal to the threshold energy plus extra is converted into the kinetic energy. Okay. So if I now use the formula for energy of photon, I will say that Hc by, or rather I should first talk in terms of frequency. H nu is equal to H nu naught plus half mv square. What is nu? Frequency of incident photon. What is nu naught? Threshold frequency, minimum frequency that the photon should have so that the electron can be ejected, right? Velocity of ejected electron. Any doubts to anybody in this formula? EI h nu, ER h nu naught, Ke half mv square. And this kinetic energy, if it is applied in the reverse side, is termed as stopping potential. Now see what I mean to say. Now see, I am hitting this particular marker by my finger, so it is moving out. Say it is moving with some velocity. If I apply the same amount of energy from other side, say I am tying it like this, I am applying the same amount of energy from other side. Now when I hit, it will just come out of the atom, but it will not be allowed to move. Why? Because we are stopping the electron from moving, right? We are stopping the electron from moving in a particular direction. You understood my point? What is stopping potential? Kinetic energy only is the stopping potential. But see, if the electron is moving in this side, if I apply energy on this side, so this will be stopping potential. Now see, I can also convert this into hc by lambda, or first, let me read lambda naught plus half mv square. Now theoretically some expressions have been asked from here in the exams. First, see, now see, I am taking hc common. Now 2 goes in the numerator, m comes in the denominator. V square. Or simply I can say square root of this was the expression asked in the exams. What is the relation between velocity of the ejected electron and the wavelength? But this thing only is termed as the threshold h nu naught is termed as work function. Or this threshold energy is work function. The minimum amount of energy required to remove an electron is termed as threshold energy or work function. Both are one and the same thing. Okay? So this is one of the formula, right? The next one, see, h nu minus h nu naught is equal to half mv square. So 2h by m, nu minus nu naught is equal to v square. or V is equal to square root of 2h by m minus nu naught. So this is the formula of velocity in terms of frequency, velocity in terms of wavelength. They can ask you this part. Okay. Now, two very important conclusions over here. If we increase the energy, or rather I should say the frequency of incident photon. See beta, when I am increasing the frequency of incident photon, basically I am increasing its energy, isn't it? Increasing the energy, okay? If you increase the frequency of incident photon, that is, you are increasing the energy, what will happen? See, suppose if this is 10 and this is 15, so kinetic energy will be 5. But if you make it 25, what will happen? This will become 15. Okay. So if you increase the frequency of incident photon, the kinetic energy of ejected electron increases. Okay, fine. I hope all of you have understood this point. Whereas if we increase the intensity of incident radiation. Now what do you mean by increasing the intensity? Number of photons are increased. So now what will happen if you are increasing the number of photons? The number of photoelectrons ejected increases. Beta, intensity is number of photons. Suppose, देखो बेटा, one photon will eject one electron. So if 4 photons are coming, 4 electrons will be ejected. Simple. Say, if this is the surface, this is connected to a bulb. What happens? The light strikes this surface. So electron is ejected from here. Sorry. The photon, this is where the photon is coming from, this side. It strikes the surface. The electron over here is ejected and it strikes this. So circuit is completed. Fine. As a result, this bulb starts glowing. Okay. This is how you create a photovoltaic cell. Copied? Okay. Now let us solve some questions on the photoelectric effect. Just one more thing you will be requiring. In questions, there is a unit which is used, 1 eV. This is 1 electron volt. This is equal to 10 raised to power minus 19 joules. 1.6, sorry. Okay, this is the information that you will be requiring.